What's up, guys? This is Waleed, and today's problem is the horticulture project. So we have some water here that's gonna pour in this cup of water. They gave us the distance that between the upper cup and the lower cup is 0.52. Right there, let me change the color. Right here. And then the height of where the hole is 0.17 meters. So the first question, what's the gauge pressure on the top of the water in the first can? So I'm saying it's 0. That's what the answer they give us. And I think because the water is going, like if there was a plug in here, then yeah, we can find the gauge pressure. But if not, then when we do the equation, P1 minus P2, we got GH minus half V squared. This value will be equal to 0 because all the potential is going to transfer to kinetic energy on the bottom. So this differential will be 0. Okay, and the same thing with the second question for the same reasoning. I could be wrong, but the answer is 0 for both of these guys. So now what's the velocity of the stream of water exiting the bottom of the first can? So for this guy we use, let me pull up again, V equal square root of 2 G H, and H in this case is, let me just call it H, and 2 times 9.81 times 0.17. Okay, for this guy I got, put that in, I got 1.82 meter per second. So now remember, this value is when the water, let's say this is the water thing, put blue. So the water is going in this direction, 1.82 in the x direction. Let's call for z axis. This is x, this is y. So it's going in the x direction. Okay, so x positive. I need to clear that up because in the second question it's might confuse somebody. So how long does it take for the water to fall to the second can? All right, so the velocity initial at time equals 0. The velocity in the y direction is equal to 0. So v initial is equal to 0 in the y direction. Okay, so v final squared is equal to v initial squared plus 2, and then the acceleration is just g, and then x. Let's call it y actually, so it doesn't confuse people. Delta y. Okay. So we know delta y is just 0.52 meters, and we know that velocity initial is equal to 0. So v final is equal to square root of 2 times 9.81 times delta y, which is this guy, 0.52. And for this one I got 0.3, no, hold on, 3.19 meter per second. Okay, so now let's find the time. So v final is equal to v initial plus gt. So we know v final, which is 3.19, divide, and the initial is also still 0, times 9.81. So this is the time now. So t is equal to 0.3255 seconds. Okay, so this is for number 4. All right, now how to the right of the first can should center of the second can be placed? So they want where should this be? Okay, they want a distance from here to here. So we know that the time it takes for the water to drop from this guy here down to here, it takes it 0.3255. Okay, so we need by that time for the water to be in the middle. So that means that x is equal, okay, so let's call it delta x, or x is equal to times velocity of x, okay, and this is vx. So time is 0.3255 times 1.82, okay, and for this guy it was 0.5924 meter. Okay. Alright guys, hope this helped. If you have any question, leave it in the comment section. I'll try to answer it. Take care. Bye.